Welcome to the Deep Dive. Today, we're jumping into some really exciting AI research. We're looking at a paper introducing InternVL3.5. It's a new family of open-source multimodal models from Shanghai AI Lab. And honestly, this isn't just, another small update.
No, definitely not.
It feels like a pretty significant leap forward in how these models actually reason, how versatile they are, and maybe most importantly, their efficiency.
Absolutely. InternVL 3.5, it really brings three big innovations together. You've got Cascade Reinforcement Learning, that's for supercharging the reasoning part.
Okay.
Then there's a Visual Resolution Router, or VR, for making image processing much more dynamic and efficient.
Dynamic, right.
And finally, Decoupled Vision Language Deployment DVD, which is all about optimizing the hardware side of things.
And the results they're reporting are, genuinely impressive. We're seeing things like up to a plus 16.0% gain in overall reasoning performance. That's huge.
It really is.
And maybe even more eye-catching, a 4.05x inference speedup compared to the previous version.
Yeah, that speedup is critical.
Exactly. And their biggest model, the InternVL3.5 it's setting new state-of-the-art benchmarks for open-source MLLMs across a ton of tasks. It's really closing that gap with commercial giants, like, say, GPT-5.
It's getting much closer.
Plus, and this is big for the community, all the models, all the code, it's publicly released. So let's really dig into how they managed to pull this off.
Okay, so maybe let's just quickly unpack the situation here. Multimodal large language models, MLLMs, they've evolved so fast, haven't they?
Oh, absolutely. It's incredible.
It's not just about what's in this picture anymore. Now it's complex reasoning, agentic tasks, even interacting with GUIs.
Right, the scope is much wider.
But there's often been this noticeable gap, wouldn't you say, between what the big commercial models can do and what open source models offer. And for you, the listener, if you're an AI researcher or an ML engineer, a massive hurdle is always the cost, the computational cost.
That's exactly right. As these MLLMs tackle more complex sort of real-world stuff, think reasoning about text within images, solving math problems visually, or even embodied agent tasks.
Yeah, the tough stuff.
Commercial models have often had the edge. And for open source, a really persistent challenge has been finding, first, a reinforcement learning framework that's stable, effective, and scalable for MLLMs.
Right. RL for these models is tricky.
It is. And second, just managing those ever-increasing compute costs that come with high-resolution images or understanding long visual sequences. You need that for the advanced tasks, but it's expensive.
So for you listening, trying to build or experiment in this space, this is probably a familiar pain point. How do we get open source models to really compete with the proprietary ones without, breaking the bank on compute? This paper seems to be aiming right at that sweet spot, addressing those compute and capability bottlenecks that you might be wrestling with in your own MLLM projects. They're offering some pretty concrete solutions.
They really are. Architectural and training solutions. So let's get into the specifics. How exactly did the InternVL team tackle these big challenges? Let's imagine you're that engineer hitting a wall with reasoning power or deployment costs. How does InternVL 3.5 help? Let's start with that core reasoning innovation, Cascade Reinforcement Learning.
Okay, so Cascade RL. It's actually a very clever two-stage strategy. Think of it as course-defined. It's designed specifically to boost reasoning, but to do it efficiently and stably.
2 stages. Okay, what's the first one?
The first stage is offline reinforcement learning. They use something called mixed preference optimization, or MPO. This basically acts as an efficient warm-up phase.
A warm-up, how does that work?
Well, MPO combines ideas from things like DPO, direct preference optimization, but also adds quality and generation objectives. It learns efficiently from a pre-existing set of good examples or rollouts.
So it uses existing data.
Exactly. That allows for more stable convergence, and you get a strong baseline performance, but with much less computational cost than if you just jump straight into online methods from the beginning.
That makes sense. Sort of building a foundation efficiently. But you mentioned combining offline and online RL. That sounds like it could be tricky. How did they make sure the stages work together smoothly? Did they risk losing the gains from the first stage?
That's a really good point. Integration is definitely key. So building on those high-quality rollouts that MPO refined, the second stage kicks in, online reinforcement learning.
Okay, stage 2.
For this, they use an algorithm called Guided Sample Preference Optimization, or GSPO. Now, this stage is about further refining the model's output, making it even better.
How does GSPO differ?
Critically, it operates without needing strict reference model constraints. This freedom allows the model to generate its own rollouts during training and dynamically explore potentially better ways to answer or reason. It pushes performance higher.
So the stability from MPO lets GSPO really focus on just getting better.
Precisely. It avoids getting stuck. And this whole progressive improvement strategy, this two-stage cascade, it resulted in up to that plus 16.0% gain in overall reasoning performance on tough benchmarks like MMMU and MathVista. Big gains, but achieved much more efficiently in terms of GPU time compared to just using one potentially less stable RL method.
That is clever. It's like, yeah, building a strong core efficiently, then using precision tools for the final polish. And for listeners maybe working with limited compute, this suggests even that first offline MPO stage could give you significant, bang for your buck early on.
Definitely. Even the first stage adds substantial value.
Okay, so Cascade RL tackles the reasoning, the intelligence. What about efficiency? That's often the killer bottleneck. And here, InternVL 3.5 brings in, as you said, the Visual Resolution Router, VRR, and Decoupled Vision Language Deployment, DVD. These sound fascinating.
They really are game changers for efficiency. These two working together achieve pretty remarkable inference speedups. Let's start with VRR, the Visual Resolution Router. Imagine, like a smart switch built right into the model. For every patch of an image, it dynamically assesses it and decides the best visual resolution needed for that specific patch.
So it doesn't just use high res for everything.
Exactly. It can compress the visual tokens, say down to 64 tokens from maybe 256, for patches that are less important semantically or maybe redundant.
How does it learn to do that without hurting performance?
That's where the visual consistency learning, or VCO stage, comes in. It's a lightweight training phase where the model learns to be consistent. It gets penalized if its predictions change too much when using the dynamically compressed tokens compared to the high-res ones.
I see. So it learns to compress smartly while maintaining accuracy.
Precisely. It forces the model to become robust to this dynamic resolution. And the result, they found VR can reduce the number of visual tokens by up to 50% with almost no hit to performance.
50%. That's huge for the input processing load, especially if you're dealing with lots of images. Okay, so that's VER. What about decoupled vision language deployment, DVD? You said it optimizes hardware. Sounds like a bigger architectural shift.
It absolutely is. DVD is all about being hardware friendly and maximizing parallelism. Think about how these models usually work. You have the vision encoder processing the image and the language model generating text. Often they run on the same GPU and can end up bottlenecking each other.
Yeah, I can see that. The vision part might be heavy, then the language part waits, or vice versa.
Right. DVD changes that. It intelligently deploys the vision encoder, which does the heavy image lifting, and the language model on separate GPUs.
Separate GPUs?
Yep. So you have a vision server processing images into compact, meaningful features. Those features then get sent over to the language server. It creates this asynchronous parallel pipeline.
So they work truly in parallel.
Exactly. The vision part is often highly parallelizable anyway, dealing with image patches. The language model is more sequential, autoregressive. Separating them lets each part run at its own optimal pace, on hardware potentially better suited for it, alleviating those bottlenecks.
Okay, that makes a ton of sense. DVD maximizes GPU use, boosts efficiency. This feels like more than just a speed up. It's almost a new way to think about deploying these complex models.
It really is.
For anyone listening who's wrestled with GPU memory limits trying to run high-res multimodal models on one card, this DVD approach must sound like music to their ears.
Definitely.
The flexibility, you could scale vision processing independently, allocate resources better. It opens up possibilities for high-res, multi-image, maybe even video applications that were just too difficult or expensive before.
And the numbers back it up. The paper shows DVD alone can speed up inference by up to 2.01x.
Wow.
And when you combine it with VR, the smart resolution switching, they achieve that total 4.05x inference speedup.
4 times faster. That's a massive reduction in compute overhead for actually using these things in the real world.
It's a profound difference.
But, technical brilliance is one thing, real-world impact is another. So how do all these clever ideas, Cascade RL, VR, DVD, actually translate into performance on the benchmarks? When you put InternVL 3.5 through its paces.
Right. The proof is in the pudding, as they say.
Exactly. These innovations sound fantastic, but how does the model perform in the trenches? This is where it gets really interesting, seeing if the theory holds up.
It really does. The paper presents results across, 35 different benchmarks. And consistently, InternVL 3.5 is right at the top among open source MLLMs.
Leading the pack.
Yeah. And most impressively, that large InternVL 3.5 241B A28D model It significantly narrows the gap with the top commercial models. They estimate the gap on general multimodal capabilities is down to just 3.9% compared to systems like GPT-5.
Only 3.9%. That's
Right.
remarkably close for an open source model.
It's a huge step for the open community.
Okay, let's break that down. What about those really tough areas, like multimodal reasoning and math? You mentioned the benchmarks MMMU and Math Vista. How did it do there?
Huge gains there. Seriously impressive. Scores of 77.7 on MMMU, that's the one with university-level questions across different subjects,
Challenging.
and 82.7 on Math Vista, which mixes visual and text reasoning for math problems. These scores are right up there, among the best for any open source model. You can really see the impact of that Cascade RL framework, scaling effectively from the smaller 1B models right up to the 241B giant.
And they mentioned something about test time scaling. How does that boost things further?
Right, that's like giving the model extra thinking time when it's actually generating an answer. It involves two techniques. One is deep thinking, basically, prompting the model to generate step-by-step reasoning first.
Like showing its work.
Exactly, like humans do.
Oh.
The other is parallel thinking, which uses a best-event approach. The model generates several possible answers in parallel. And then a separate, smaller critic model, they use one called Visual PRM V1.1, evaluates those candidate answers and picks the best one. It's like getting multiple opinions and choosing the most convincing. Both techniques together give an extra boost, especially for complex reasoning.
Interesting. So multiple strategies to enhance reasoning quality. Now, you mentioned something earlier that really caught my attention. It's language capability.
Ah, yes. This is a really striking finding. You might expect that adding all this complex vision processing could dilute the language skills, maybe lead to some catastrophic forgetting.
That's often a concern, right?
It is. But here, InternVL 3.5 actually improved on the language abilities of its base LLMs, like the Qwen 3 series it was built on. It outperformed the original language-only models on most standard text benchmarks.
So becoming multimodal made it a better language model.
It seems so. It strongly suggests that this rich multimodal training doesn't just add vision, it can actually enhance the underlying linguistic understanding, making the model more holistically intelligent. It's not forgetting language, it's getting smarter at it because of the vision input.
That's a really powerful insight. Multimodal training isn't a trade-off, it's potentially synergistic.
Yeah.
Okay, what about agentic capabilities? This area is exploding right now. GUI interaction, embodied agents.
Yeah, this is super exciting. InternVL 3.5 shows really promising results here. For understanding SVG's scalable vector graphics, it hits state-of-the-art among open models on the SGP benchmark.
Useful for web understanding.
Definitely. And for GUI tasks, like navigating software interfaces, it performs very competitively on benchmarks like ScreenSpot and Oswald G. It even challenges models like GPT-4o on WebArena Lite v2. The paper notes a score of 11.7 for InternVL 3.5 versus 1.9 for GPT-4o there.
Quite a difference. And embodied tasks like spatial reasoning.
Strong performance there too. On benchmarks, testing spatial skills, VSI Bench, ERQA Space 10, OmniSpatial, it does really well. And interestingly, even their smaller InternVL 3.5 Run-B model gets state-of-the-art on VSI Bench, beating out much larger models. Shows the efficiency extends to capability per parameter too.
Very efficient. And quickly, how about other areas like OCR, document understanding, multi-image comprehension?
Consistent leadership there as well.
Yeah.
Especially in OCR, chart, and document tasks. You see clear improvements as the model scales up. Even the smaller 2B model significantly outperforms older models on things like DocVQA and InfoQA.
Okay.
And for handling multiple images or complex real-world scenes, tested on benchmarks like Bealing, Mantis Evo, Real World QA, it again shows robust performance, often beating both open and sometimes even closed-source alternatives. It seems genuinely good at dealing with the messiness of real-world visual data.
It really sounds like a well-rounded improvement across the board.
Yeah.
And the whole project, the fact that they're releasing everything, the models, the code, that's just such a huge contribution back to the AI community, isn't it?
It truly is. It's not just saying, look what we built. It's saying, here, you can build with this too.
It pushes everyone forward.
Exactly. And the paper includes detailed ablation studies, which are really valuable. They carefully test removing each of their main innovations, Cascade RL, VR, DVD, to show how much each one individually contributes to the overall games.
Right, proving each part pulls its weight.
Precisely. For instance, they show that Cascade RL, just after that first offline MPO stage, already provides significant average gains, like plus 3.5% on reasoning tasks. It gives researchers concrete evidence and practical insights.
So InternVL 3.5 isn't just a set of powerful models, it's almost like a blueprint, wouldn't you say? A demonstration of how to advance multimodal AI, effectively boosting reasoning, versatility, and efficiency all at once.
I think that's a great way to put it. It's a clear signal that open source efforts can absolutely compete at the highest level, and it provides valuable lessons on how to build these incredibly complex systems more efficiently.
So wrapping this up, what does this deep dive really mean for you, the listener, if you're that AI researcher or ML engineer?
Well, it means you now have access to incredibly powerful, efficient, and versatile open source tools.
Tools you can build with, experiment on, learn from. It feels like it genuinely closes that gap we talked about earlier, the one between open source and top commercial models, in a way that maybe seemed quite far off just a short while ago.
It really does. It empowers you to tackle more sophisticated problems, potentially with less computational burden.
Which leads to a fascinating final thought, perhaps. As open source models like InternVL 3.5 keep pushing these boundaries, getting so versatile and efficient, are we maybe entering a new phase?
What do you mean?
Well, maybe the main differentiator between models won't just be about raw performance numbers anymore if open source can get this close.
I see. You're thinking maybe it shifts towards other factors.
Exactly. Could it become more about, say, the unique ethical frameworks embedded in a model, or innovative deployment strategies like DVD, or maybe highly specialized agentic capabilities fine-tuned for specific domains?
That's a really interesting point. If core capability becomes more democratized through open source, the unique value might lie elsewhere, in the how and the why, not just the what.
So the question for you listening becomes, with these powerful, efficient open source tools like InternVL 3.5 now available, what new frontiers will you explore? What new applications will you build? What problems will you redefine?